folks. Today we're going to be talking about waves.
No, Jill, not those kind of waves.
Oh, not those guys.
Alright, class, what is a wave? Susan?
Like this?
No, Susan. No. Okay, Julia?
A wave is a disturbance that carries energy through matter or space.
You got it.
These 2 points right here are the crests. These are the 2 highest points from equilibrium. These 2 points right here are the troughs, which are the lowest points from equilibrium. From equilibrium to the trough, or from equilibrium to the crest, is the amplitude. This line drawn here is the wavelength. A wavelength is the distance from crest to crest, or from trough to trough.
This is an example of a mechanical wave. A mechanical wave is a wave that requires a medium to travel through. In this case, the medium is the water.
Mom, I broke it! You did not. Look it! I did! I broke a glass!
Now we're going to demonstrate a constructive and destructive interference. Maria! Not that kind of interference. This is an example of a constructive interference. As you can see here, we have a smaller wave and a larger wave. They interfere in the center and they create an even larger wave, and then they continue on in their path that they were going, and the larger wave is now over here and the smaller wave is over there. This is an example of destructive interference. This is a wave above equilibrium, and that is a wave below equilibrium. As they interfere in the center, they create a small wave above equilibrium. Then they continue in their separate paths, and this is now the wave below equilibrium, and that is the wave above equilibrium.
Transverse waves are waves that particles vibrate perpendicular to the motion of the wave.
Alright, here's an example of a transverse wave.
And here's a transverse wave with larger amplitude. Oh wow, look at that.
Now do smaller amplitude.
And smaller amplitude,
Look at those crests.
look at those little crests and troughs.
A wave is a wave whose particles vibrate parallel to the direction of motion of the wave.
Here's an example. Sound waves are an example of longitudinal waves,
Notice how it stretches and compresses.
parallel to the motion of the wave.
Longitudinal waves have compressions and rarefactions. A compression is a region in a longitudinal wave where the particles are closest together. A rarefaction is a region in a longitudinal wave where the particles are furthest apart.
The speed of a wave is equal to frequency times wavelength. So if we have a wave with a frequency of 200 hertz and a wavelength of 2 meters, velocity equals 200 times 2, so the speed of the wave is 400 meters per second. In the video we're saying
Waves. Not like that, Bethany. Look at all these waves.